We're just going to preview this quiz on basic chemistry. And we'll go through them one by one. Y'all decide for yourselves what you think the answer is. And then I'll tell you what the answer is. Okay, so question 1, positively charged subatomic particles are the protons. No problem with that. Yeah.
Is there any way of maximizing that?
The problem with maximizing it is that the projector's not set to the size of the screen. So what I can do is probably enlarge so you can see it better. And then do some scrolling adjustments. And again, for the people hearing the recording, we're working off 2 different screens here, and it's just going to make us crazy and slow things down. Okay, so what did we say? Positively charged? And y'all can read that better now, right? Okay. So question 2, the element whose symbol is Na. Sodium. We got this. Not nitrogen?
No.
Why not? Starts with an N. Does anybody know why? Natrium. And you need to know that because some of the hormones are named for their effect on sodium, but we don't call them sodium affecting. We call them, you can say natrium if you want. Okay. But natriuretic peptide has to do with sodium. Okay, so you do need to know those word roots. Does anybody know why potassium is a K instead of a P or a PO? Anybody? The Latin name for potassium is kalium with a K. So that's why. All right, where are we? Question 3, the element whose atomic number is 8. Oxygen. Some of these, now in my test, I'm providing a periodic table. You guys that are in Dr. Boucher's, feel free. Have I got enough chairs?
Yeah.
Looks like it.
Morning.
There's a chair right there in the front. And if we need more, we can do it. Sure, yeah. I'm fine with that. And if we need to move to a bigger room, I suppose we could. But, and I also told him, and I'll tell you again, since more of you have walked in, if at any point you decide you're satisfied with the review and you're ready to go, this is come and go. So you leave when you're ready, but when you leave, where do you go from this room? Back to your cap, or if you're in my class, you can go to the testing center and take your test. Okay? All right, so where were we? Question 3, the element with atomic number 8. Oxygen. And again, I'm providing a periodic table for my test, so just saying, if you're in Dr. Boucher's class, you might want to casually mention that to him. Unless there's one in your classroom, is there? I think there might be one on the wall in your classroom. Have you ever looked? There isn't? Well, you tell them you need one. That's why I do that, because when I teach in a classroom, there's one on the wall in the class. And so I really don't have a lot of choice. The element with atomic weight. What's the difference between atomic number and atomic weight? Plus the neutrons. Very good. Okay. So y'all got a pretty good handle on that then. And this, for some reason, is not moving. Okay. So what's the answer then? Hydrogen is the only one, the only element that has the same atomic number and atomic mass number. The atomic weight is kind of a misnomer. It should be called atomic mass number. Okay, look at the list, and sometimes questions are written that way. You have to look at your choices and pick one out. The molecule is listed with ionic bonds. Sodium chloride, that is like the one we always teach, the example of ionic bonds. So sodium and chloride consists of a sodium ion and a chloride ion. And what about water? What kind of bonds? Polar, covalent. And what about ammonia? It's not ionic, right? So if it's not ionic, then what's the basic other choice? If it's not ionic, it must be covalent. Those are your only 2 fundamental choices. If it's not ionic, it's covalent. But if it's covalent, is it polar or nonpolar? What about in ammonia? Okay, what's the formula for ammonia? Now, I know my students know this. NH3, and I gave you a list of 2 bonds that were polar covalent bonds. What was on the list? This is really important. OH is one, NH is the other. So what was ammonia? What's the formula for ammonia? NH3. Is that a polar? It's actually 3 little polar bonds, so that's polar covalent. Okay, and then what about carbon dioxide? Ooh. We never really looked at the structure of that in class. What's the formula for carbon dioxide? Everybody should know this one. CO2. And how many bonds does an atom of carbon always need to make? 4. And what about oxygen? This should be rolling off your tongues, okay? Oxygen 2, carbon 4, nitrogen 3, hydrogen 1. Memorize that list. That's a short list to remember because it's 1, 2, 3, and 4. Hydrogen 1, oxygen 2, nitrogen 3, carbon 4. Those you should definitely have down, okay? So carbon dioxide, oxygen only makes 2 bonds, carbon needs 4. Is everybody happy in a molecule of carbon dioxide? Oh, yes, they are. So it's CO2, right? So how do I do that? Could you write it? If a double bond is shown with a double dashed line, what would CO2 look like? Looks like that. That's CO2. Okay? Polar or nonpolar? Notice that the carbon's in the middle, oxygen symmetrically on either side. Polar or nonpolar? Why? Why do you want to say polar? What does it mean to be polar? Do you have a concept of what that means? It means the electrons are unequally shared between the 2 atoms. So imagine this as a tug-of-war. This oxygen's tugging at carbon's electrons from one side. The oxygen on the other side is tugging at the electrons from the other side. They're equally matched. If this were a tug-of-war over the carbon, would either side win? No. So they're tugging equally, which means nobody wins, which means an equal distribution of electrons. So that being said, polar or nonpolar? Nonpolar. Carbon dioxide, nonpolar, and that's an important thing to remember because that determines whether it can get through the membranes or not. Okay? And we'll get to that, I hope. All right, where are we? 6? Six says 2 elements that often form polar covalent bonds between them are? Between them, meaning like one between with one and the other. Is oxygen and nitrogen a possibility? No, why not? They're both big molecules. So again, what was that list of polar covalent bonds? It was a list of 2. NH and OH are the only, well, they're the major polar bonds you need to remember. So do you see either one of these on this list? Yes. Where is it? Hydrogen and oxygen? Is that right? Any questions about that? Okay, a compound that forms hydrogen bonds. Now, listen carefully. If I'm making hydrogen bonds, I'm bonding either 2 different molecules or 2 different regions of a very large molecule like DNA, or a protein can actually be big enough to fold over to make a hydrogen bond. So what does it take to make a hydrogen bond? You have to have a hydrogen, right? What else do you have to have besides a hydrogen? Doesn't have to be water. It has to be something else that's polar or ionic. So stop and think, if I am pulling electrons If I have a bond between oxygen and hydrogen, or it could be nitrogen and hydrogen, who's bigger? The oxygen or the hydrogen? Oxygen. So doesn't that mean this guy, the oxygen, has more protons, more positive charges, therefore able to pull the electrons more strongly than little bitty old hydrogen? So, and electrons are positive or negative? Electrons? Negative. So if the electrons are being pulled towards the oxygen, that makes the oxygen a little bit negative. So what does that make the hydrogen? A little bit positive. Not ionically, a whole electron's worth, but a little bit positive. So if the hydrogen is a little bit positive, then it can be attracted to things that are a little bit negative. Okay? It could be ionically bonded things, but in general, when we're talking about making hydrogen bonds, it's between the hydrogen of one polar bond and the oxygen or nitrogen of another polar bond. Okay? So hydrogen bonds in general are going to be between hydrogen and something else that's polar. Is oxygen polar? What does it take to be polar? Here's oxygen, O double bond O. Remember that polar means unequal sharing of electrons. So if it's exactly matched, like oxygen gas, hydrogen gas, chlorine gas, doesn't matter what, anything bonded to itself is a non-polar bond. Does everybody see why that would be? Because there's no inequality here. They're both the same size. So anything that's symmetrical, like carbon dioxide, or bonded to itself, like oxygen gas, non-polar. Put that in your non-polar bucket. Okay? So can it be attracted to something polar if it's non-polar? Polar and non-polar? Nope. Not attracted to each other. One's hydrophilic, the other's hydrophobic. Right? Okay. So then the answer to this question is not oxygen. Is water polar? Oh yeah, it is. Now, what about our other choices? Methane? Definitely not. It's not on our list of things that are polar bonds. That was a real short list. What was on our list? OH and NH, that's it. CH not on that list. CH non-polar. Anything bonded to itself, non-polar. So that rules out methane and hydrogen. Everybody okay with that question? Okay, question 8. The energy of motion is? Kinetic energy, that one's easy. Let me get caught up with my online group here. Okay, question 9. How many hydrogen atoms are in glucose? This is just a question. Can you read a molecular formula? 12. That one's easy. All right, let's just move on from there. Unless there are questions. Everybody okay with that? Yeah. Okay, question 10. A reaction in which a molecule is broken down into smaller parts. This is a definitional question. Can we do that one? Decomposition. Okay, and what's the opposite of that? Synthesis would be building up. What about anabolism? What does that mean? Building up. So it's a synonym for synthesis, right? What's the synonym for decomp? Catabolism. And then what do we do in an exchange reaction? What's an exchange reaction? You break them apart and swap parts. So it's very simple. All right, question 11. What's the function of an enzyme? It speeds up, but be careful, read the question all the way through. I have two choices here that say speed up. Lowers the activation energy. In other words, it reduces the amount of energy required to have a chemical reaction proceed. Any questions about that? Okay, the next one likewise is a definitional question. If there are no carbon-hydrogen bonds in an atom, is it, or in a molecule, is it Organic or inorganic? Inorganic. Organic things in general have to have at least one carbon-hydrogen bond. Now, if you're an organic chemist, not a biologist, you would also put CO2 as an organic chemical because CO2 is used to make those things. Biologists don't care what chemists think. I don't care that I'm recording this. Biologists in general, yeah, we tend to focus just on the organics that we care about, and to us, carbon dioxide is generally not classified that way. So if you ask an organic chemist, they'll say, yeah, if it's got carbon in it, it's organic. And we're just going to say, we don't care what you think. Okay. All right, question 13. Which of the following is not a property of water? You had sort of a laundry list of properties of water that you were supposed to read about. If you were in my class, I didn't lecture on them. Did Dr. Boucher lecture on these? Yeah, it's pretty easy to read. It's very descriptive. So what do you know about water? Is it an effective lubricant? Yes. Absolutely. You use it as a secretion in your joints and on your serous membranes to help reduce friction. Is it involved in chemical reactions? Absolutely. Most of the organic synthesis or decomposition involve either adding water or taking it out. Does it have a high heat capacity? Yeah, you use it in sweat because it takes a lot of heat off your body when it evaporates off. Does it dissolve any chemical? No. Can you give me an example of things that it doesn't dissolve? Fats and oils, lipids in general. Okay, so we often refer to water, I think it's very sloppy to say it's a universal solvent, but you'll hear that said. It's not a universal solvent. It's an almost universal solvent. So we really ought to be more specific about that. Okay, a chemical that does not dissolve well in water. This is just a definition. Yeah, looking at your choices here. Hydrophobic and hydrophilic have opposite meanings. Philia is attraction, phobia is repulsion. You could say loving and hating, but that's an emotional term. So if you're looking for a non-affective term, chemical term, repulsion and attraction is what we would say. So chemicals that do not dissolve in water are hydrophobic. Question 15, the way we measure free or dissociated hydrogen ions in a solution, that is what? pH. That's pH. And that gets confusing to people sometimes. So if you have questions about how pH is measured, now would be a good time to ask. Anybody? Why is pH 7 neutral? Because the acid and alkaline or basic parts are equal in concentration. And that concentration in water at room temperature happens to be, the negative log of that is 7. Okay? So I went over that in class, so if Dr. Boucher's class has questions, you can ask. Is everybody okay with that idea, just the basics? Okay, question 16, and we're not responding, so I'll read it to you off my other screen. Did it come back finally? Good. A solution is neutral if what are your choices? No hydrogen ions at all? Not likely. More base than acid, that would definitely be basic, right? More acid than base, same hydrogen ion concentration as pure water. That is probably as close as we're going to get to a correct answer. In fact, it's neutral if the hydrogens equal the hydroxyl, the OH negative ions. Okay, next question. An acid dissociates in solution, separating off its hydrogen ions and lowering the pH. Does that sound right? No. An acid dissociates in solution, separating off its hydrogen ions and raising the pH? Yes. Accepts hydrogen ions? Okay, so we've got two parts to this definition. So does an acid dissociate and release hydrogen ions, or does it accept hydrogen ions? An acid?
Releases and lowers. Releases and
It releases and lowers. Releases hydrogen ions and lowers the pH. So if you have trouble remembering this, can you remember something that's acidic that you already knew was acidic? Lemon juice, vinegar, something like that. So the pH of acids is less than 7. Okay, so something that's acidic, coffee is very acidic. It has a pH of about 5. Sodas are acidic, pH of about 4 to 5, somewhere in there. So low pH means acid, okay? Y'all have got to remember that. And in fact, in years past, I've threatened my students not to let them out of the room at the final exam if they cannot tell me that acids lower the pH. At some point, it's going to come back to haunt you that you don't know that. Oops, that's not right. And one of the first things I do in A&P 2 is ask students, if I add acid, does the pH go up or down? If I add acid, does the pH go up or down? I'm asking you. Down. Don't forget it. Okay, so question 18 is about buffers. What's the job of a buffer? Keep it from changing at all?
Very much.
Keep it from changing very much. So it works to counteract the acid, but just because of the nature of chemical equilibria, it cannot stop the pH from changing at all. But if you added straight acid to plain water, the pH might drop to 3, whereas with a buffer it might drop from 7 to 6.8. Okay, so it's going to change. It's going to drop. If you add an acid, pH is going to drop. It's just, if it's buffered, it's not going to change very much. Okay, so now for question 19, we have a list of substances, and I'm asking you which one of those is a strong acid. Sodium bicarb, hydrochloric acid, carbonic acid, sodium hydroxide. Hydrochloric acid is a strong acid. What does it mean to be a strong acid? It means when you put that in water, it completely dissociates. Every little molecule of HCl will separate into an H and a Cl. It donates all the hydrogens it has, every one of them. Anything less than that would be classified as a weaker acid, but there are some acids that are weaker than others. And at this point, we're not asking you to learn a range of them. But of the ones on your list, which one is a weak acid? If hydrochloric is a strong acid, well, there's one up there that has acid in its name. Carbonic acid, that's a fairly weak acid. And then what about the other two, sodium hydroxide and sodium bicarbonate? What are those? Those are bases. One of them is strong, one of them is weak. Which one is which? Hydroxide strong. Sodium hydroxide is a lye. Okay, so, and I would encourage you not to play with any of these chemicals at home, but you can buy Plumber's Helper. What is Plumber's Helper? It's a liquid solution of lye. It's sodium hydroxide in very concentrated form, and you definitely don't want to be playing with that stuff. Okay, so that answers question 20, which was, what was our answer? Sodium hydroxide. What does that leave sodium bicarbonate to be? It's a base. It's just not as strong a base as sodium hydroxide is. All right, so let's see how we did. I have 2 unanswered questions. Did I miss hitting some? I just got carried away, no doubt.
There you go.
And the one below that is marked wrong.
Okay, it's marked. I marked it wrong? Okay, yeah, definitely want to fix that. So what was the answer to the function of an enzyme? Lowers the energy of activation.
That should be in our.
Yeah, you're right. Number 19 is wrong. Oh, yep. Did I get any of the other ones wrong? All right, I'll have to see how I did with my online class. I have no idea whether it's going to tell me how I did. Let's see. Okay, looks like I did all right. 20 out of 20. Yay. All right, let's do the next quiz. Does anybody have any other questions about basic chemistry that you want to go over?